Got a few more best practices to again raise the quality of this model as a tech transfer document, and also help you to build models more successfully. I just want to mention, for model building purposes, the Analyze button in the Excel environment is quite powerful. This can be used to perform a quick check as you build that everything so far within the model build is consistent, and you can also do a quick parse of the model. Same thing that happens when you press the simulator or fitting or optimization buttons, and it will tell you here if there are any issues encountered. So just to give a quick demo of that, I'm going to change the name of one of the components, click Analyze, and it will tell me that there is a problem in my model, and if I double click on any of these, it will highlight the cell in which the problem exists. So that can be a useful feature for detecting any issues that might exist with your model as you build. Just fixing that back to ethanol. Another one continuing in the same vein from the last event. Typically we like to keep the process tab free of values other than values that are in a sense absolute and won't vary with scale or operating conditions. So right now the UA that's provided on process, that should really be moved to another worksheet. I hope you can guess before I can get to the end of this sentence which worksheet that should be moved to. It is the scenarios worksheet. So I'm just going to do that. I'm going to do the same with the coolant flow rate, and you probably could have a pretty good go at this yourself by now, but I'm going to just sort of do it slowly. I hope you can see the logic in what I'm doing. I'm going to just put a 3 for each of these two values, and going to do something similar with the coolant flow rate. So I just need to move out a little bit further, and coolant 1 is the name of within the model, that's the name of the heat transfer fluid. Going to put a 1 there and a 1 there. Actually, in this model there's a pretty significant change in volume, so I'm going to also allow for that by providing a value of SUA, the rate of change of UA with respect to volume. I'm going to just copy the UA column and insert one beside it. I'm going to write SUA there. It's in watts per liter Kelvin, and I'm going to provide a value of just 1 for that for now. Other parts of Dynochem allow you to either estimate or fit these numbers for volume dependent heat transfer calculations. So you can see there I'm gradually taking away numbers from the process tab. So right now the only numbers that we can see in the top two sections are for CP. Similarly for the feed tank, it's just CP. That's because I feel that's a number that's not going to vary. Minimum volume for the feed tank, I'm going to be quite comfortable to almost fully empty the feed tank at any scale. Reaction kinetic parameters, those belong on the process tab. So we're even closer now to a fully best practice process tab with really all of the factors, if you want to use that terminology, that may vary from one run to the next, listed on the scenarios tab. That's kind of getting that model in really almost optimum shape. If we run this model in simulator now, again it'll reflect any changes in the inputs that we've made, but one sort of nice consequence of the change we've made there is that the set parameters list will now show all of the parameters that are probably of interest to change. There's no need for us to right click and choose all parameters. The default shortlist are most of the things that we might want to change in practice and see the effects. So I'm just going to rescale to QR there one more time so you can see that's very consistent with where we were before. and just going to exit simulator at that point. Finally, for tech transfer purposes, it can be nice to include some information about the equipment that either was used for this process or will be used for this process. And these features to the left, especially catalyst, but also properties, allow us to look up from the equipment data service information about the equipment that we used. And this chemistry has all been done in a vessel called LR01, Lab Reactor 01, and that is available in my equipment data service. So I'm just going to retrieve information about Lab Reactor 01 and enter that in this catalyst pane. And all of this information about the details of that reactor will be saved with the model, and if we share this model in any way, then the end user will be able to see all of this information by clicking on the Catalyst button. We can also visit the equipment data service. Obviously you have to sign in because it's a very secure system, and once we've signed in, we can get a look at Lab Reactor 01, and of course within this environment we can also start to look at all kinds of other reactors that we might use for this process, either now or when it's further developed. So just a couple of additional best practices there on improving the quality and the structure of your model and making it an even better tech transfer document.